Okay, some more properties of determinants. So we're going to look at some transposes and some row operations and see how they affect determinants. We've already seen this. We saw this in this theorem here. Gaboom. So this is appearing earlier in your notes. So we'll make use of this guy. You don't have to copy it into your notes now unless you want to. So we're going to make use of this to solve this problem. Now, what we're going to do is try to make use of this information, of course. And we're going to say, well, look at number 5. It says that if I take a multiple of one column and add it to another column, then the determinant does not change. Now look what I can do. I can take twice the second column, and I can add that to the first column, and I will simplify my life considerably. So let's recopy the matrix for now. It's a 2 by 2 matrix. So if I do, let's say, column 1 plus 2, column 2, what happens? Well, this disappears. So I get A, B, C, D. And because of number 5, we know that these two determinants are the same. Now, I'm getting closer to my information. I want to use this information. I got one more step. I got to transpose. Okay, transposing a matrix does not change the determinant. So we get 7 here. Now, this is because the determinant of A transpose is the same as determinant of A. Okay, so I'm taking a funny looking matrix, I'm doing some operations, and I'm relating it back to some knowledge I have. Okay, part B is going to refer to part 3 of the theorem here. How so? Now we know that if we take a matrix and multiply a row by a constant, then we are also multiplying its determinant by that constant. So what this ends up telling us is that A, B, 3C, 3D, it gives us a nice formula. It says that if you have just one row or one column with a common multiple, you can just factor that thing out. And this is part 3 we're using here. So this equality is justified by part 3. All right, then we have just 3 times 7 is